Everyone, welcome to today's lesson. So today we're looking at engineering mathematics. My name is Hampton. So last time we did how to come up with differential equations. Now today we're going to do the other way around. We're going to be solving differential equations, and then this is what we're calling the solutions of differential equations. So in the last example, if you remember very well, we had this this part here, and this example, and then we made we made a differential equation by eliminating the arbitrary constants, which were a and b, and we came up with this differential equation. This was an example. So now today we're going to be moving from last time we're moving from this to that. Today we're going to be moving from this to that. From this differential equation to just a particular term, particular equation. So differential equations of the first order and first degree. So we'll discuss the standard methods of solving differential equations of the following types: equations solvable by separation of variables, homogeneous equations, linear equations of the first order, and exact differential equations. So today we're just going to do 3, and then the other 2 will do them when we meet in the next lesson, but today I'll just explain 3. So I also forgot to put direct. There's also supposed to be direct integration. There's also supposed to be direct integration, and then we have separation of variables, we have homogeneous equations, we have linear equations, and we also have exact equations. So my prayer is that we do all these before we open. So the first one is this one here. This is solvable by direct integration. So this one is known almost by everyone, even you know how you can solve this. So in other ways, we are trying to find an equation or a solution of this differential equation. How can you find a solution of this differential equation? So first of all, what you do is you cross multiply here, so you just remain with dy this side, and then you have 24x to the power 24, let me just do this, 24x to the power 3, and then plus 6x squared, and then all these in brackets, then we say dx. So here now it's just a matter of introducing the integral symbols. So we have we're going to integrate dy. We also integrate this part with respect to x. So 24x cubed plus 6x squared. So we put this dx with respect to x. So now when we integrate dy, we'll get y. So in other words, we're integrating 1 with respect to y. When we integrate y 1 with respect to with respect to y, we'll get y. And then when we integrate this equation here with respect to x, we're going to have 24, and then this is going to be x to the power 3. So we add plus 1 this side, is going to be 4, and then divide by 24 divided by 4 will give us 6x to the power 4. Then this one will just give us 2x to the power 3 when we integrate, and then we say plus c. So don't forget to put the constant c. So this is how you solve the equation. This is how you get the solution of a differential equation. So sometimes you might be given to say find the solution of this differential equation, or find the particular equation. So when they tell you to find the particular equation, it means that they are going to give you maybe to say when y is equal to 1 and when x is equal to 0. They can give you such a thing, and what you just need to do to find a particular equation is just when you find this, you come and put 1 where there is y. You also come and put x 0 where there is x to find the value of c. Then once you do that, you simplify, you find the value of c, and then you find the final equation, which is called the particular equation. So let's quickly move on to the next session. So we now look at separation of variables. So separation of variables. So if, for instance, the differential equation can be written in this format, we say that the variables are separable. Why? Because we know to say they are this one is a function of y. When you have a function of y, then you also have a function of x. Don't be confused by this phi you are seeing here. It can be g of x, it can be f of x, it can be what, I don't know, but it's also just a function. So if you can write any function in this format, then we say the variables are separable. You can separate the variables with respect to their differential coefficients. So we get the solution by integrating both sides. It's just almost the same as what I'm explaining. There's no difference. The difference is just very small. So the working rule when you are dealing with separation of variables, first of all, you have to separate the variables as this format. You need to separate the variables and then they're supposed to be in this format. And then second step, you integrate both sides. After integrating both sides, you integrate this part with respect to y, this part with respect to x. After that, you add an arbitrary constant c. After integrating, you add the arbitrary constant c on the right hand side. Okay, so let's look at an example. So the question here is saying solve the equation 4xy dy dx is equal to y squared minus 1. So the first step, remember what we said on the first step here, we separate the variables. So when we separate the variables, we're going to have something like this. Or before I do this, let me first separate it with so when we're separating the variables here, we put those with y on one side and those with x on the right side. So those with y, we can say, if I want, I will say 4y, and then 4y, I'll put dy there. Then I'll divide everything by this, since this also contains y. So I'll divide everything by that. So y squared minus 1. So this is just going to be equal to 1 over, when I divide everything by x this side, 1 over x, then dx. So here now it's just a matter of after this now it's just a matter of integrating. The first step was that we separate the variables. Those with y, we put them on one side, those with x, we put them on the other side. Then the second step was that we integrate both sides. So this side we can integrate using u substitution. U substitution, where you say let the denominator that. So we say let u be equal to y, sorry, this is y. Let u be equal to y squared minus 1. So you find u prime, rather you find du dy. Du dy will simply just give you 2y. And then you make dy the subject. So dy is just going to be equal to 1 over 2y du. So after that, you now, where there's dy in this equation, you replace with 1 over 2y du. So when you replace with that, we're going to have the integral of 4y over 2y u du when you replace there. So you can see that this y and that y will go. We just remain with 2 into 4 there. Just remain with 2 over u, the integral of that. So the integral of that with respect to u will just give us the ln. If you want, you can use ln, or if you want, you can use log. You can say log u or ln u, there's no problem. Ln is just a special logarithm. So after differentiating this part, the other side you are going to have, when you differentiate this other side, so let me just do this. So we've differentiated one side, we've integrated one side, so we are saying ln, so you can either use ln or log, there's no problem. So ln u, so ln u, we know to say our u was just y squared minus 1, so we can say ln y squared minus 1. So there's supposed to be a 2 here, this 2 there, I forgot to write the 2. Okay, and then this is equal to, when you integrate this with respect to x, 1 over x with respect to x, you get ln x. So here now it's just a matter of yeah, I think it's even done. Once you integrate, you do this, you are done. If you want, you can now take these two on top this side, you do all those, you know how you simplify logarithms. So if you want, you can simplify it, or if you want, you can leave it in this format. Okay, let's see how this how the solution is. Yeah, so this is what I was talking about. You just separate the variables. After separating them, you integrate both sides. So after integrating both sides, you use u substitution to integrate, and then you're going to get this as your solution. Sorry, in my solution I forgot to put a c at the end. That was the last step which I missed. So I'm supposed to add a c at the end, which is this one, the constant. So okay, so this is what we do. So this separation of variables is just as simple as this. You don't have to stress or to struggle in solving this. Just take heart. Yeah, you follow the 3 steps. So example 2. So example 2 is this one, which says solve dy dx is equal to x. So sometimes they will not tell you to say find the differential equation, or find the, they will not tell you to say find the solution of this. They'll just tell you to say solve this. So how do you solve this now? So first thing first, we separate the variables. So when you separate the variables, we're going to have something like this, where everything that contains y, we put them together with dy, and then everything that contains x, we put them together with dx, like this. So after separating the variables, you now integrate both sides. So you integrate both sides. When you integrate sine x, you get negative cos x. When you integrate this, so when integrating this, you use integration by parts. You can't integrate this directly, you have to use integration by parts. Okay, so even here, when you're integrating this part of x log x, you use integration by parts. So don't be confused by this log. If you want, you can use ln, you know, to say ln x, the integral of the integral or the differentiation of ln x, dy dx of ln x, sorry. So when you're finding the ln x dx this will just give you 1 over x, and then when you integrate this you get ln x. So same applies to log. Then when you differentiate log x, you simply get 1 over x. Ln and log, they're just the same things. It's just that ln is a special logarithm. So after introducing the after integrating both sides, you also add the constant there. Then you begin to integrate. So when you integrate sine y, you get negatives cos y. When you integrate this part, you use integration by parts, which is this part. And then same applies to here. When you this x times 1, you get x, which is here. You are integrating x alone. And then this 2 log x, when you integrate it, you use integration by parts. So here they've not yet used the integration by parts. Yeah, so here the integration is done. This side they are now using integration by parts to integrate this part. Okay, so when you simplify this part, you can see that this cos y and that are cancelling, meaning you're just remaining with y sine y. Then this other side, you also have certain things which have to cancel, which are we have certain things which are going to cancel here. Okay, so you can see when you simplify this further, you are going to get this expression here. Okay, you're going to get this expression. So let's quickly move on to the next one. So this is how simple these things are. Don't even be stressed or what when solving them. They are simple and straightforward. So I'm trying to be fast because the slide is a little bit long, but if you have any questions, you are free to ask me or contact me on WhatsApp. I'm going to explain to you where you don't understand or where you missed the point. Yeah, so integration by parts you can look up in John Bed and even other engineering mathematics books. You'll find it there. So let us look at now homogeneous differential equations. Or before we go to this, let's just do a quick recap on separation of variables. So separation of variables, first thing, you separate the variables. After separating the variables, you integrate both sides. After integrating both sides, you add the constant c. Then you are done. So it's just as simple as that. So let's quickly move on to the next one, which is homogeneous differential equation. So in homogeneous differential equations, let's take for instance, you have this kind of differential equation. Okay, normally it's in the form which is like this. You have both x and y on the numerator and x and y on the function which is on the denominator. So when you look at separation of variables was dealing with equations where maybe for instance you have dy dx on this side, and then on top this side you have the function of x, and then down here you have the function of y. This was separation of variables. Now instead of using f here, they were using phi. Same applies to this part. But in this one, in homogeneous differential equation, you are going to have a function which contains both x and y. Even on the denominator, you have a function which contains both x and y. And then you see what you're going to do. So first of all, you need to say let y be equal to vx. Let y to be equal to vx. Then in all these equations, you do as is, you replace where there is y, you put vx. So for instance, if you have 2x on top plus 3y, maybe you have 2x squared plus 3y. Where there is y here, you replace with vx, so that you have x throughout the equation, both on the numerator and and on the denominator. Okay, so now what happens is this. So after letting y be equal to vx, you can differentiate this. Yeah, you can differentiate this by product rule. So dy dx using product rule, you discover to say v when you differentiate x, you get v times the derivative of x. Derivative of x will give you 1. So 1 times v, you get v, and then say plus, you say x, the derivative of what's this? The derivative of v, when you differentiate v with respect to x, will give us, yeah, so the derivative of v with respect to x using what's this, implicit differentiation, is just dv dx. So where there is dy dx, we're going to be replacing with v plus x dv dx. So here you change it, you replace with that, and then where there is y in this expression, you put vx. So let's see what I'm talking about. So this form of a differential equation is called a homogeneous equation if the term if each term of f of xy and phi of xy is of the same degree. So if you have the same degree, on top the highest degree is 2, and even the denominator the highest degree is 2, so you consider that to have differential equation to be a homogeneous differential equation. And then in such a case, you say y is equal to vx. Yeah, you say y is equal to vx, and when you differentiate this using product rule, implicit differentiation, you get dy dx v plus x dv dx. Yeah. So the reduced equation involves v and x only. This new differential equation can be solved by variable separation. Yeah. So when you reduce the equation, it will only contain v and x alone, because where there is y, you have replaced with vx. Yeah. So having done that, you are going to have an equation which is going to be solved by separation of variables. You can easily separate the variables. After integrating by separation of variables, you come back again, you come and say v is equal to, you make v the subject in this equation, you're going to have v is equal to y over x. So meaning in the final equation, wherever you're going to have v, you're going to put y over x. So this is the working rule. So step 1, put y is equal to, so in step 1, put y is equal to vx, and then when you differentiate that, you get dy dx to be that. Yeah. Then you replace it in the equation. Then step 2, you separate the variables. Step 3, integrate both sides. Then the last step, you put v is equal to y over x and simplify. Right, let's look at an example. Solve the following differential equation. This is the equation. So first of all, we put it in the format of a homogeneous equation. So it's going to be like that. You just simply divide by 2xy plus, you divide by this 2xy. In short, you just make dy dx the subject of the formula. And then when you look at the degree here, the degree of the numerator is 2. The highest degree of the denominator is also 2. So meaning the degree of the numerator and the denominator is equal. So meaning this is a homogeneous differential equation. So first step, we say let y be equal to vx. So we say let y be equal to vx. So while there is y here and there, we'll put vx, and then while there is dy dx, we're going to replace with this v plus x dv dx. That's the way we solve those questions. And then on substituting, the given equation becomes this. So while this dy dx, we're going to put v plus x dv dx, and then where there is y, we are going to be putting vx. So while there is y, we put vx. We are going to have, since y is squared, we are going to have v squared and x squared. This is what we've gotten here. And then here 2xy, so x is going to be squared, and then we're going to have v. When we put vx while there is y, this is what we're going to have. Yeah. And then the denominator there, x will also be squared, and then you're going to have v. Here we're going to have x squared. Yeah, since we don't have y here. So here what to do now, you can simplify. You can see that this x, that x is going, that x is going. You do what is, you simply what can I say, you simply divide by x squared. You can see that x squared can go into both the numerator and the denominator. So when you simplify it, you're going to have something like this. You only remain with v this side, and then we have only one x this side. So what you do is you pair the like terms. So this v will go to the other side of the equal sign. So we're going to take this v to the other side of the equal sign, so that here we just remain with x dv dx. Yeah, so after taking v to the other side of the equal sign, when you simplify, you find the common denominator and everything. This is what you're going to have. Then when you simplify, the numerator there is going to be this. This is what we're going to have on this side, and then this side we're still remaining with x dv dx. So now here we can use separation of variables, because we know to say we only have two variables in this case. So you can whatever contains v, you take it to this side, meaning we're going to cross multiply here to have dv, to have 2v plus 1, and then divide by this, divide by v squared plus v, and then we have dv. And then this other side, we're just going to have 1 over x dx. I hope you've seen how I've done this. Then from there we can now integrate both sides. We integrate this side and that side. We also need to have, to add a constant there. So integrating this side, we can simply use u substitution. So we can say let the denominator be equal to u, and then you use u substitution to integrate. This side is straightforward, it's just ln x. So this is what you're going to have. So yeah, that's what you're going to have. Then using you introduce the integral signs on both sides, and then when you integrate this part using u substitution, you're going to have this. And then when you integrate the other part using using just a normal differentiation, the power rule, the change rule, you're going to get this. Yeah, you're going to get this part alone. And then this one is just c, but this c can also be written as log c. There's no problem, because it's just a constant, we don't know it. Then from there you can simplify it further if you want, but if you don't want, you can leave it here. But in most cases, to earn more marks, it's better you simplify it further. So you can see to say all these contains my logs. So what you can do is you can you can just, if you want, you can just remove them, though there are rules attached to that. But what you can do is you bring this side, this side, that side, then you simplify. So this is what you are going to have. Yeah, so you know to say when you're adding two logarithms, you simply multiply the functions there. So we multiply c times x, and then this side, and then we just remove the verses, and then you so remember what we said. Here this function that we have here, this function that we have contains v and x, but our main function here does not have any v. So meaning we recall to say we once said y is equal to vx. So meaning we make we make v the subject in that expression. So we're going to have y over x. So while there is v here, you put y over x, and then you simplify it to that. So if you want, you can simplify it. If you want, you can leave it the way it is. Okay, so let's continue. Oh, the lecture is even done. I thought we had some more notes in front. So this is an exercise that I've given you, and then you can solve it. After solving it, make sure that you send your solutions through on WhatsApp, and then once you send the solutions, I'll check through and I'll see whether you have made any mistake or not. But remember, when they ask you to find a particular solution, they'll give you the conditions here. So use these conditions to find the final answer. Yeah, and then this one is just a matter of solving on this one. You just solve the differential equation. Same applies to this one. So I don't know the methods you are going to be using. You need to choose from the methods that we've learned. You need to choose which method is ideal for these equations that I've given you, for each of these equations that I've given you. So thank you very much for watching this lesson. See you next time in the next lesson. Shalom, shalom.